Welcome back, and this is a problem for the practice test. For test 2, it's a force of 1 Newton will cause on a 1 kilogram body to have an acceleration of 1 meter per second squared. So I have the body of 1 kilogram. I apply a force of 1 Newton. What it will make a force of 1 Newton? It will produce an acceleration. If there is force, there is acceleration. And the acceleration is the force per unit of mass. Because force is mass by acceleration. So the force is 1, and the mass is 1. So what it say, the problem? It say that the acceleration produced by a force of 1 Newton is 1 meter per second squared. It's true. It's true that. Thus, it's followed that a force of 9 newtons applied to a mass of 9 kilograms will cause it to acquire an acceleration. Now I have a force of 9 newtons applied to a body of 9 kilograms. So 9 newtons is applying to 9 kilograms. So the force produces acceleration, and the amount of acceleration that will produce is the force per unit of mass. 9 newtons divided between 9 kilograms. So the result will be acceleration equal 1 meter per second squared. Do you agree? Now let's go to solve this second question. It says a plastic ball in a liquid is acted upon by its weight and by a buoyant force. So it's a force that's going up. You know that this force exists when you try to submerge a body on water. There is a force going up. This is the buoyancy. And it says that the magnitude is 4.4 newtons. It says that the weight is 2.6. So on the body, I have 2.6 going downwards. I have 4.4 going upwards. Going upward, and at that given instant, the ball has 0 velocity. Okay, has 0 velocity. So at that instant, an external force acting on the ball, if it has 0 velocity, it means that it has 0 acceleration? What you say, Mayor? If a body has 0 velocity...
It's either that or the object is massless. It has to be one of the two.
No, if an object has 0 velocity instantaneously speaking, it doesn't mean that have 0 acceleration. For example, imagine this body. This body, imagine that there is a force in this direction. The body is moving in this direction. The velocity is decreasing because the object was moving in this direction, but the force is in this direction. So the velocity is decreasing. The force is acting on the body. Eventually, the body will stop. His instantaneous velocity will be 0, but the force is acting on the body. There is an acceleration in this direction. So the body will start to move in this direction with an increasing velocity to the left. So the fact that the velocity is 0 doesn't mean that the acceleration is 0. Indeed, acceleration means the change in velocity divided by the change in time. Is v final minus v initial. The fact that v initial is 0 doesn't mean that the A is 0, because it could be a process when v initial is 0 and v final is minus 3 meters per second. So there is acceleration. The fact that at this point there is velocity, the velocity 0 doesn't mean that the acceleration is going to be 0. The acceleration is going to be 0 if v1 is 0 and v final is also 0. Now, yes, the change in velocity will be 0 and the acceleration will be 0. But in general, if the velocity is 0, it doesn't mean that A is 0, because v after some time can be -3 or +3, so there is acceleration because there is a change in the velocity. Okay, so now let's go to do the problem. The problem say that there is an external force acting on the body. There is the weight, there is the buoyancy, there is force 2.6 going downwards, there is 4.4 the buoyancy of the water. The water does a force on the object of 4.4. And there is an external force, and what it say that the external force, taking in account this force, the acceleration of the body is 3 meters per second squared in this direction. So what the problem is asking is, what is the force, this external force, that produce that the object is going to accelerate in this direction 3 meters per second squared? So what you will write, you will say the sum of all the forces equal the mass by the acceleration. You are going to write this equation in the y direction. So you are going to write the force of the sum of all the forces in the y direction equal the mass by the acceleration. What are the forces acting on the y direction? I see the weights going downwards. I see the external force going downwards. And I see B going up, so it's going in the opposite direction as the acceleration, minus B, equal the mass by the acceleration. mg is 2.6. F external is an unknown. I don't know what is the external force that produced acceleration 3 at the end when I sum. This is what I want to find, the external force. V is minus 4.4. So 2.6 minus 4.4, well, the external force will be m3 or 3m plus 4.4 minus 2.6. So the external force will be 3 by the mass is say 0.26, I think, plus 4.4 minus 2.6 plus 1.8. So 3 by 0.26 is 0.78 plus 1.8 is around 2.58. So around 2.60. So the force external that is acting on the body that produces this acceleration going downwards should be 2.6 newtons going downwards. Is clear? Now let's go to solve this problem. It's say two bodies, P and Q. Okay, P is more massive, so I use the letter capital M. Q is less massive, so I use the letter little m. Two bodies, P and Q, perfectly smooth surface, are connected by a light core. This is the light core. I suppose the mass of P is greater than the mass of Q. An horizontal force is applied to Q, as shown in the figure, and accelerating the two bodies to the right. If the force is in the right direction, the acceleration has to be to the right. There is no possibility that you apply a total force to the right, and the acceleration is to the left, because the force, the total force, is the mass by the acceleration. So the acceleration follows the total force. So if the total force is like this, the acceleration must be here. It must be in the same direction, because m times A, let's say 3 times A, if the mass is 3, is the force. You see? Is the force 3 times A. If the mass is 3 kilograms, 3 times A should be the force. So if the A were in the opposite direction, 3 times A will go to the left, so it will never be equal to the force. So you see that it's important to realize that the force and the total force and the acceleration follow the same direction. So in this problem it says, the magnitude of the force exerting by the connecting core on the body P, on this one. What is the force acting on this body, on the big massive? Is the same like this one? No, we have to calculate the force. So let's go to calculate the force acting on P, Fp. So we know that the capital M is bigger than little m, or M is smaller than capital M, or M divided by M is less than 1. There is any problem with this? No, I don't think there is no problem with this. If capital M is bigger than M, means that M divided by M by capital M is less than 1. So what happened with the body of capital M, with the P, with this? There is a force acting on the body, Fp. What is this force? This force is the force that the rope is doing on P. This force is not acting on P. This force is acting on Q. So the force acting on P is Fp. And it's the force due to the rope. The rope is making a force to the right. So the force acting on P is the total force. The force acting on P is Fp and is the total force. And the total force is the mass by the acceleration. So it's the mass by the acceleration. So mass by acceleration, but I don't know the acceleration. So I need to find the acceleration. So to find the acceleration, we imagine like this. This is my system. My system is a system of two masses, capital M and M. Total mass, capital M plus M. What is the acceleration that this force will produce? This force will produce on the system an acceleration to the same direction as the total force. So how I will apply Newton's law to this system? I will say the sum of all the forces, F is equal M plus M multiplied by A. So the sum of all the forces, the F, I don't know what I put the P, the F is equal to the M, so the acceleration if the F divided by capital M plus M. Do you agree? Do you agree from the moment, Major?
Yeah.
Okay, so this is the acceleration. But this is the acceleration of this one, and also the acceleration of little m is the same acceleration. They accelerate together. They make a change in the velocity together. So this is the acceleration. So I will take this amount of acceleration and I will plug in here. So plugging this amount, I will have that the force acting on P due to the rope is the mass by the acceleration. This is the acceleration F divided by M plus M. So it will be M plus M. Let's go to work it here. The force acting on capital M. Capital M. I don't know why I put the P. I don't know. Because it's the object P. Well, it's the object capital M. It's the same thing. Okay, the force acting on capital M is the mass by the acceleration. But I found that the acceleration of the system is the F divided by the M plus M. How I will work this to compare the force acting on M with the force is external force F, that is this one. How I will compare this force F with the F of P, of F of M, of capital M. How I will compare? The way to compare is to remember these things. M is bigger than M, or M is smaller than M, or M divided by M is smaller than 1. So I will take this expression and I will divide the numerator by M and the denominator by M. I have not altered anything because I have divided the numerator by something and the denominator by the same thing. So now the force acting on M, or what I have called the force acting on the object B, is the same thing, is equal to M divided by M is 1. F is the force, the external force apply the one that is here, see with this F. F is this force. So the force will be F, and now I can make something here. M divided by M is 1, plus M divided by M. But M divided by capital M, you see, M divided by M is 1, and M divided by little m is less than 1. Okay, so it's something, F, the external force, divided by 1 plus something positive. Something that is smaller than 1, maybe 0.1, the relation between M and M. Maybe M is 1 kilogram, maybe capital M is 10, so it's 0.1. So it would be 1 plus something. 1 plus something is something bigger than 1. So F divided by F divided by a number that is bigger than 1 is smaller than F or bigger than F. If you take the F and you divide by something bigger than 1, let's say by 2, what will happen? That F of M will be smaller than the force. Catch it? Catch it?
Yeah.
Yeah.
Okay. So
Would this be true if the P object P was not heavier than Q? Would it still be true?
no. No.
Then it would be accelerating faster than the other one, correct?
No.
It'd be equal?
We can do the problem. It will be the same problem, and you can do the same problem exactly. Now this is the F. If you want, we can do it. Now this is little m. This is capital M.
Can we do it instead of capital M a different letter so we don't get confused?
No. Now we change the problem and we say this is the problem that we want to find, and we want to find the force on little m. Okay?
Yeah.
Okay, the acceleration will be the same one. The acceleration will be the force, the total force. So I will study this system, the system of two bodies where this is the only force, the external force. This is the external force. So the force, the acceleration, the force produces acceleration. So this is the acceleration of the two objects. The two objects, capital M and little m, is moving with acceleration, and the acceleration is the force divided by m plus m. From now, it seems to me that there is no change. Now this is the acceleration of the two bodies. What is the force acting on little m? Is the mass by the acceleration. The mass by the acceleration, the F divided by the m plus m. Now, let's go to evaluate if this is bigger than F or smaller than F. Before, it was smaller than, in the first case that we studied, the force acting on this one was smaller than F. Let's go to C, is now the force is smaller also. So how I will work with this? I will divide by m. So the force acting on m equal, I will divide the numerator by m. So if I divide by numerator by m, the F will appear. The 1 will appear, and n divided by m will appear here. Right? You see what I did?
Yeah.
I have divided the numerator by little m, and then denominator by little m. So this m will cancel with this m. This m with this m is 1, and it will appear m divided by m. But now, wow, m divided by m is bigger than 1. Before it was smaller than 1, so the force the force will be now 1 plus something. The force will be now m divided by m is bigger than in the other case. So I have a bigger denominator that will produce a small force. Now the force acting on m is smaller than the F. In the other case, it's also true that the force is also true, but this force is it's difficult.
Smaller than the previous case.
Right. It's smaller than the previous.
But I'm saying in general, because you might switch the question.
So let's go to record this. If you have, for example, m and m, the same masses, and you have the external force, the force acting on this one that create the acceleration A, going in this direction, it will be F divided by 2. Why? Because the acceleration of the whole system of the two masses will be the force divided by the mass, m plus m. So it will be the force divided by 2m. And this will be the acceleration A of the system. Now, this body, m, is moving with acceleration A equal F divided by 2m. So it means that the force acting on the body, the force, the force acting on the body, let me erase here, the force acting on m, the force acting on m is the mass of the object by the acceleration of the object. But the acceleration of the object is F divided by 2m. The m will cancel, and the force acting on m will be the external force divided by 2. Okay? So the rope will do a force F divided by 2. Okay. Now let's go to solve this problem. This problem say like this. It say figure 4.5, it show two forces, F1 and F2. F1 have a magnitude of 9.6, F2 is 3.2 to the left. What third force will cause the object being in equilibrium? Being in equilibrium means that the acceleration is 0. If the acceleration is 0, the sum of all the forces are 0. So I need a third force, so I have F1 minus 9.6i, F2 3.2j, F2 3.2j. The sum minus 9.6i plus 3.2j. The sum is this vector, you see? Is the sum of this plus this. F1 plus F2. F2 is here, so this is the total force. So if I have a total acceleration, I need a force that is going to be with the same magnitude but opposite direction. So this is the third force that I have to add to make a sum 0. This plus this will make a sum 0. So I have F1 plus F2, this amount. What will be the F? Well, the opposite of this force, because the sum will be 0, so this is the force. Which one is the opposite to this force, to this vector? Well, plus 9.6i, plus minus 3.2j. This is the opposite force. This is the force that is opposite, and I'm sure that the sum now will be 0. Minus 9.6 plus 9.6 is 0. Plus 3.2j minus 3.g is 0. So this, I found the force. I found the force that I have to add to F1 to F2 to make 0 acceleration. So 0 acceleration, because if the sum of the forces is 0, means that this is m by a, so the a is 0. Okay, perfect. So the force, this force have a magnitude. And the problem is asking about the magnitude. What is the magnitude of this force? Well, 9.6 plus 3.2, 9.6 squared, plus 3.2 squared. If you calculate, I think it's almost 10 newtons. So the magnitude of this force is 10. And the tricky question that I was reading on this problem that it say what angle counterclockwise is in this direction, rotation like this, counterclockwise, but it say from F1. F1 is here. So what he's asking is this angle. This angle is the angle that is asking. The angle that makes the force with F1. So I find this angle better, and I subtract 180 minus this one. Do you agree? So this is the force F, this is F1. So the problem is asking, this is the F3, this force, okay? The problem is asking about this angle. This angle, let's go to call it theta. So this angle is with the force F1. So what I say is that I know the magnitude of the F. The magnitude of the F is the 10. Now I'm going to find this angle, alpha. And I will say the theta is 180 minus alpha. Do you agree? 180, everything. I take it alpha, I will obtain theta. So theta is 180 minus alpha. So let's go to find alpha. So the vector F3 is this one. This is the vector F, the third vector, that is 9.6 minus 3.2. What is this angle? Well, tangent of alpha. Tangent of alpha is 3.2 divided by 9.6. I don't have to consider the minus 3.2 like negative. I'm looking for this angle, and I will know how to subtract. So this angle is 18.50. 18.50 degrees, not radians, no? So the angle alpha is 180 minus the 80. So this is F1, and this angle is everything, the plane angle, the 180, minus this angle that I found, that is 80. So 180 minus 18 is 162. So as a conclusion, the magnitude of the force is 10, and the angle with F1 is 162. Okay? And the problem is solved. Okay? Catch it? Okay, now let's go to do this problem that say you have a body. Indeed, we don't need to the magnitude of the force T is closed. It is asking by the magnitude of this force. So you have the body has the weight downwards. There is another force going downwards. There is the tension, and there is the tension. And this is equilibrium, I suppose. Let me see. And external the force is the not 20. They are in equilibrium, so the sum of all the forces are 0. So what is asking is, if the force is 410, what is the tension? What is the magnitude of the tension if this force is 410? So the mass is 6 kilograms. What are the sum of all the forces through the y direction? Well, the sum of all the forces through the y direction is the mass by the acceleration. But the acceleration is 0 because the body is in equilibrium. So this is 0. And what are the forces? I see this force, the component of the tension, T cosine of 30. I see the same one, T cosine of 30, of the other force, of this one. So it's 2T cosine of 30. I see the weight going downwards, and I see the force F going downwards, this force. So 2T cosine of 30 is equal mg plus F. Solving, so the mg is 6 by 10. The force is 410. The problem say that is 410. So total 60 plus 410 is 470. So 2t's cosine of 30 is 470. So the t is 470 divided by 2 cosine of 30. So it will be 430 divided by 2 divided by 2 is 1, square root of 3. So this is the tension. You make the calculation and you see which one is the correct one. If I didn't make any mistake, that I don't think that I made any mistake. Is that problem clear? Yes. For the x direction, there is no information that I can obtain because the sum of all the forces is the mass by the acceleration in the x direction. The sum of all the forces in the x direction is 0 because the acceleration in the x direction is 0 because the object is in absolute equilibrium, so the acceleration x is 0. So what are the forces in the x direction? In the x direction, there is this force, let me put it here. There is the tension here, the tension Tx, and there is another force, the component of T. What is the magnitude of this? The magnitude of this is T sine of 30, because this is the 30. So T sine of 30 is the magnitude of this. So T sine of 30 going to the left plus T sine of 30 going to the right will be 0, of course. Of course, the sum of two equal, the subtraction of two equal things will be 0. So there is no information that I can get from here. All the information is on the y direction. So what it say this problem? You have this system of two masses. This mass is unknown. This mass is, it has the tension going up. Let me read it because I don't remember. Block A of mass 7 kilograms, this is block A, and block A unknown, the mass is unknown, are attached to a rope with mass. A 60 newtons force is applied. This force is 60 newtons. This one horizontal force. 60 newton force is applied horizontal to the block A. The purpose of this force is to create a normal force. So the purpose of the normal force is that if there is a normal force on A, there is friction on A. That's why they want to put this force P. Okay, it's a keeping it in constant with a rough vertical face. The coefficient of static and kinetic friction are 0.4, 0.3. 0.4, 0.3, 0. Okay. The pull is like friction. The mass of the block X is set out so that the block A is on the verge of slipping upward. So the mass A is going to. Let me read. Maybe I made a mistake here. Is on the verge of slipping upward. So it's on the verge means that it didn't slip yet, right? So the mass of the block is closer to. Okay, let's go to find the solution to this problem. So this is the body. Our purpose is to find the mass of this body. The mass of A is known. The mass of A is 7 kilograms. Okay. So I'm going to apply Newton's law to the object A, to the mass of A. And we know that it's going to be acceleration in this direction. So if going to be acceleration in this direction, it means that we need more force going up than going downwards. Okay. Let's go to apply Newton's law. If I apply Newton's law to the x direction, the sum of all the forces will be 0, because on the x direction, there is no acceleration. The body is accelerating upwards. So the sum of all the forces is in the x direction is equal to the mass by the acceleration, but the acceleration in the x direction is 0. So the mass by the acceleration will be 0. So what are the forces acting on the x direction? On the x direction is the 60 newtons going to the left and the normal force going to the right. This produces an equation. The sum of all the forces equals 0 is the n going to the right, minus the 60 going to the left, and this allows me to find the normal force. The normal force in this case is 60 newtons. Okay, so I will remember that I know the normal force. Now I'm going to apply Newton's law in the y direction. The sum of all the forces in the y direction is the mass by the acceleration of the y direction. And the acceleration is going upward, like I have said at the beginning. So what are the forces acting on the body in the y direction? So I will choose the positive direction as the acceleration going up. So T is positive. T is positive. The friction is negative. The weight is negative. And this is mass by acceleration in the y direction. I didn't write AY, but it is supposed that it's the AY. So the tension minus the friction minus the weight is mass by acceleration. But it say a subtle thing here, the problem. It say, yes, it say that the block A is set so that the block A is on the verge of slipping upward. So it's on the verge, it's going to slip, but it didn't slip, so the acceleration is zero. I have interpreted the problem like this, and we are going to make the calculation of the solution to see if I'm right or wrong. So the acceleration is zero, but it's going to have acceleration. As soon as this equation finish, it's going to have acceleration, and the coefficient was static at this moment because it didn't have acceleration, it was zero. So T minus mu by the normal minus mg equals zero. This allow me to find the tension. The tension is mu s plus n plus mg, solving from T. So mu s is 0.4. By n is 60, I found it here. Plus m is 7. 7 by 10, 70. 0.4 plus 60 plus 70 is 24 plus 70. 24 plus 70 is 94 newtons of tension force going upwards. So in this moment, indeed, there is not yet acceleration. It's going to have acceleration. The total force going up is equal to the total force going downwards. Going up is the tension, and going downwards is the friction and the weights. So what I will do, I will go, the 94 newtons is the same tension that is here on the X, on the mass and on the unknown mass in the other side of the pulley. So the unknown mass is this one, okay? And the tension is here, is the same tension, the 90. So there is 90 newtons going up and mg going downwards. So what I want to find is what is the mass. So I will say like this. I will say, let's go to apply Newton's law to this mass, to the unknown mass x. Okay, if I apply to the unknown mass x the Newton's law, what I will find, let me put it this smaller. Sorry. So what will happen here is that now the tension will go up. The mass mg will go downwards. The unknown mass mg will go downwards. And the sum will be, it will be zero, still is not moving, but it will move soon as at this condition ended, the coefficient of static friction will be going to the dynamic friction, and the coefficient is smaller, so the tension will be bigger, the 90 newtons going up will be bigger than the friction force going downwards and the weight, because the friction force will be smaller now. So in this problem, we ask about the mass, so the tension going up minus the m, the unknown m by g, the weight going downwards, will be 0. So the tension will be m by g. So the m, the unknown m's, is the tension divided by g. So it will be the 90 divided by 10, so the mass will be 9 kilograms. So the mass will be 9.4 kilograms. So it's 94 the tension, or 90, I don't remember. The 94 newtons. So sorry, here is 94, so the result is 9.4 kilograms. So let me see if you can check in the test, if this is the C is the correct result, is because I have not done any mistake.
It is. It says 9.4 is correct.
Okay, so I didn't do. So the interesting thing to understand here is, you see there is two coefficients of friction. As soon as he's going to accelerate, it will be the dynamic coefficient of friction. But the dynamic coefficient of friction is 0.3. So the force going downwards will be smaller. So the tension will accelerate the body up. This is the subtle things to understand here. That this tension is calculated when the 0.4 myostatic happen to be. But if it's still if it's not the 0.4, it's the 0.3, this will be smaller and will produce a tension smaller, but still will produce acceleration upward. Okay, this is the problem. If you want, we can go to the next problem. Okay, let's go now to do this problem. It says that this has a wheel that is rotating. The wheel have 8 meters radius, and it says that it rotates the angle 2 pi in 4.5 seconds. So the angular velocity is the angle that he rotates divided by the time that he delay in rotate the angle 1 revolution, 2 pi. So 2 pi is 6.28. 4.5 seconds, so this divided by this, I don't know how much radians per second will be. Can you tell me, Major? 6.28 divided by 4.5, it will be, well, whatever it is. So, it say after the cylinder, if a rider mass of 40 kilograms, so there is now 40 kilograms, if a rider, how much force does the rim push on her at the top of the ride? So he's here. The guy...
It's divided by 4.5 or 45?
4.5 seconds.
Okay, 6.28 divided by 4.5 is 1.3. Well, it's 1.4 essentially, because it's 395
radians per second. So this is the angular velocity, and what is 1.4 multiplied by 8? Is 11.2, right?
11.16, yeah,
11.2 meters per second. So what happened here, the problem is asking, if there is someone here of mass 40 kilograms, what is the force that the surface is doing on the object? So here is the picture. So you have the object of 40 kilograms. There is a normal force here, and there is the weight. And the sum of all the forces is equal to what? The sum of all the forces is equal to the mass by the acceleration. But in this case, okay, the sum of all the forces is the normal going downwards. The surface do a force on the guy going downwards, and the weight going downwards. And this is equal to the mass by the acceleration. But the body is rotating in a circular motion, and the normal acceleration that is in this direction, the acceleration that is going to the center, is v squared divided by r, mv squared divided by r. So the problem is solved. This is the equation that we have to use. So the equation will say that the normal force plus the weight is equal ma equal mv squared divided by r. So the normal force will be mv squared divided by r minus mg. So making numbers, the normal force will be m v squared, you said that is 11.2 square divided by 8 minus m 40 by 10. So this would be 40 by 8, 40, 11.2 square divided by 8 minus 40 by 10 minus 400. So the normal force will be how much? Can you tell me? 11.2 square multiplied by 40.
I'm putting in the calculator, 1 second.
Okay. So if we make the calculations here, Vm will be mv squared divided by r minus mg. If we plug in numbers, the v will be 11.2 square, because the velocity, I didn't say this, the angular velocity is 1.4 radians per second. So the linear velocity, the velocity at this point v, is omega by r, is the angular velocity by the radius. Omega is 6.28 divided by 4 pi, multiplied by 8, this is 11.2 meters per second. So this is the equation, and this is the result. So you plug in number here, and you will find a normal force of 225 newtons going downwards. Okay, there is 225 newtons going downwards. And this is, of course, the force that the floor is doing on the guy. Okay, let's go to do this one. This one say a 10 kilogram mass is connected with a 63 kilogram mass over the table, assuming that the frictional force is neglected. What is the magnitude of the acceleration of the 10 kilogram blocks when the other block is released? Well, they will have the same acceleration when he is released. Need to be the same acceleration because the road, if it's not an elastic road, it doesn't have elastic property, they will accelerate like the two bodies, like one only body together, like the 6. So let's go to do it. On the 10 kilogram, there is a tension. This is the only force acting on the x direction on the 10 kilogram because there is no friction going to this, to the left. So this is the total force, T, is acting on the x direction. And the total force, the sum of all the forces acting on the x direction, is the mass by the acceleration. So the T is the mass 10 by A, but I don't know the A. But I know that T has to be 10 by A. So I'll apply Newton's law now to the 63 kilograms. If I apply Newton's law to the 63 kilogram, I will see the tension, the force that the rope is doing on the object, T. I will see mg going downwards. What will be bigger, mg or T? For sure mg will be bigger than T because the acceleration is going downwards. No way the T have to be bigger than the mg. The mg have to be bigger than the T. So what is the equation that I will plug in? The sum of all the forces in the y direction for this body of 63 kilograms is the mass by the acceleration in the y direction. What are the forces acting on the y direction? The weight is positive because I choose the direction positive as the direction of the acceleration. So the weight of this mass of the 63 is mg going downwards. The T is going upward, minus T. Mg minus T is the total force. And the total force is the mass by the acceleration. So 63 by 10 minus t, but t is 10a. 10a minus ta is equal to 63a. So 630 is 73a. So the acceleration is 630 divided by 73. And if you make numbers, how it will be? Measure. What will be the acceleration?
Second plugging it in. 8.6.
8.6 meter per second square, taking in account that we have used the 10 meter per second square, but this will not make a big difference. So the acceleration should be the A. If you use G 9.8, for sure you will find this result instead of 8.6, okay? So is this problem clear? This problem is a basic problem. It's a problem that is a standard problem. You say like this. How you think? You think like this. If this body is going to accelerate, it's because there is force to the right. So there is force, the tension. So if there is force, there is acceleration A to the right. So what is the relation between the tension, the force, and the acceleration? The relation is that the T is the M by A. So because the M is 10, so the T is 10 by A. Perfect, I have the first equation. Now I will do the same thing. I apply Newton's law to the second mass of 63 kilograms. And what I will do, I will say the sum of all the forces equal the mass by the acceleration. If there is acceleration in this direction, it's because there is more force going downwards than going up. So mg have to be bigger than t. So I will write my equation for the 63 kilogram. This is the equation for the 63 kilogram. mg going downwards, positive. T going upward, negative. ma going downwards, positive. mg minus t equal ma. So I will solve for a, and a will be 8.6 meters per second square. And that's all. So, Jorge, is this problem clear for you? Christopher?
Yeah,
Yes?
this one is similar to one of the Newton's laws that you solved in the notes. So this one I understood it pretty good.
Okay,
Thank
good,
you.
good. Stephanie? Stephanie, is this problem clear for you? Edela? Well, okay. So now let's go to the next problem. The next problem says, how much work must be done by the friction force in slowing 1,000 kilogram car from 26.1 meters per second to rest? So the idea is like this. There is a body that is moving with velocity v equal 26.1. After some distance delta x, the body is at rest. So his velocity is 0. What happened here? The only thing to produce a change in velocity that is from v initial 26.1 to v final equals 0 is to produce acceleration in this direction. So the force is mass by acceleration. So the force has to be in the same direction as the acceleration. So the force and the acceleration, they goes always together, and the relation is that the force is the mass by the acceleration. So if you multiply by the mass, let's say 3, you will obtain the force. What force is here? The force is the friction force. So the force that is acting on the body is the friction force. And the friction force is stopping the body and is taking the energy out of the body. Initially, he has an amount of kinetic energy, 1/2 m26 squared. This is the amount of kinetic energy. but the friction force is making a work that is negative. The work of the friction force is negative because the friction force is going to the left. The displacement is going to the right. So the work is negative. So the friction force is absorbing the energy, the kinetic energy of the body, the initial kinetic energy of the body, until the final kinetic of the body is zero and he stops. So what did say our theorem? Our theorem say the work done by all the forces, the net force, but in this case there is only one force, the friction force. The work done is the change in the kinetic energy. So the work done is Kf minus Ki. What is Kf? 0. What is Ki? 1/2 mvi. What is the work? 0 minus 1/2 mvi. 0 minus 1/2 m, 1000, v, 26 squared. So the work is this one. If you multiply, you will find the answer. What is the answer, Meyer? What is 26 squared by 500? The work is negative, and the amount of work is
340,605 is what I got.
So this is minus 3.46 by 10 to the power 5. Okay, because if there is more zero, it will be 10 to the 6. That is, will be 1 million. It will be a million. So it's minus 3.46 by 10 to the 5. 3.46, 41 should be this one. Okay, should be this one.
Why is our answer negative and that one not?
Because they are wrong. They made a wrong answer. The answer key should be minus 3.41 because the work is negative because the only thing to decrease the kinetic energy is making a work that is negative. Okay?
Okay.
They made this mistake. How much? Because maybe they are how much, but it's a negative work.
People in the chat want me to confirm with you that test 2 part 1 is
The problem this one now. So shall we go to the next one? Any questions?
Yeah, just a quick question.
Now let's go to solve this problem. So we are going to solve this one, okay?
Professor, just as a suggestion, maybe you should put an announcement about what you're going to do for the test and the test 2 part 1 for the people.
Now we go to solve this question. A spring with a spring constant 22 newtons per meter. So the K is 22 newtons per meter. It's a stretch. So you stretch the spring an amount of 2.9 meters. So the displacement of the spring is 2.9. So of course you use a force in this direction to displace. Meanwhile, you are using this force, there is the force of the spring that opposed to the compression because the force of the spring is minus kx. So the force of the spring is this one. Minus kx is going in the opposite direction of the compression. The compression is positive, is to the right, but the force is to the left because the k is positive, so the force will be to the left. So you move this spring with constant velocity, you apply the force equal to minus kx. So as you are moving, the force has to be bigger. This force applied to the object, to the spring, have to be bigger because the other force is bigger when the x increase. Okay, so you do a work in going from here to here. You do, who is you? You is the guy that is pushing to the right. When I say you, I refer to this force. This force is doing a work, but this force is exactly the opposite force of the spring. So the work, what is the work? Work is force by displacement. What work we are calculating? The work of the force going to the right, apply to the body. Apply to to stretch the spring 2.9 meters. So the force is not minus kx. The force is k by x, because it's the force in the right direction by delta x. But the force is changing. When the x is here, is a small x, the force is small. When the x is here, the force is bigger. What it will be kx by delta x? Kx by the displacement, we can put it like this we can put the displacement like the amount, kx by delta x is well put. What it means kx by delta x? In one instance, kx maybe is this amount. Delta x is this amount, so kx by delta x is the area. This small area. Now I make another motion. The force increase, and the delta x is this small delta x. So the force by delta x is again the area, this area. So at the end, the work is the area that is behind this, is the sum of all the small work. So the work is the area that is behind this curve. The force is the area behind the force kx. And what is the area? The area is the base. The base is x. It's a triangle, you see? The area is like a triangle. You see the triangle, right? The area of a triangle is the base, the x, the 2.9, by the force, the kx, divided by 2. So the area is 1/2 kx squared. Wow! And this is the work. But this is the work of the force that you are doing, not of the stretch. The work, as I have taught you, the work of the spring is minus the change of the potential energy. But the spring, the force F that I'm talking is the force that you do. So it's the opposite as the spring. So the force, the work of the force is plus the change of the potential energy. And plus the change of the potential energy is this work, is the work, 1/2 kx squared. So the work of the force is 1/2 kx squared. K is 22, x squared is 2.9 squared. So the work is 1/2.
92.51.
1/2 11 by 2.9 by 9, more or less. 3 squared is 9, so it's 99, maybe 95.
It's 92.51.
92.51 joules is the work done. And the problem is solved, okay? You have to take care that they are asking about the work of the person that is acting on the spring. So when you do this, you store energy, you store potential energy on the spring. How many energy have you stored doing this? 92 joules goes to potential energy stored to the spring. Now the spring is, after you displace, after you make the work, now the spring have energy, potential energy, 92 joules. You have placed 92 joules of energy into the spring. Okay? Any questions? Let's go to the next one. Let's go to see what it say. Let's go to see what it say. What it said. This is someone that I was just finalizing before the. Well, this is it say too many things. We'll see if I did it correctly. Okay, this is the spring. And this is the object. You stretch the spring 0.12 kilograms. The external force is removed, so you stretch the spring. You keep it there with the compression, but you take out the force that caused the compression, so you release the energy. So the potential energy is released. The potential energy that was stored on the spring now is compression. You compress and you store potential energy on the spring. You in some way you liberate the spring, So the spring will decompress, and the energy, potential energy that the spring will have, will give you to the mass m. So it's a 0.12 block. This is the block. Is held against the spring of 35 newtons. So the force that is holding this spring at this position is K by X, and this force it says that is 35 newtons. But it doesn't say what is K and what is X. In always we will know that K by X is 35 newtons. Okay, it says the external force is removed. When the external force is removed, so it has like a click here that maintain, okay, we do this force during the distance delta x, we do a positive work, we do this force. So the work that we do is stored in the potential energy of the spring. Now the spring start when you liberate the spring, the thing that is holding the mass m, you liberate, so it will be free to move. So now the spring will exert a force to the right, and the body will accelerate. So now it starts a lot of information here that I don't know why they give us so many information. It says that after the external force is removed, the block is projected with a velocity 1.2 meters per second. So here, when there is no potential energy, because the spring has liberated all the potential energy and has converted into kinetic energy, the kinetic energy is 1/2 the mass, 0.12 by 1.2 square. So I have this kinetic energy. So the work done by the spring in stretching from the compression to this point is, I can apply conservation of energy if you want. I can apply conservation of energy. Let's go to do it with conservation of energy. So I have the spring here, compress. So I have the energy, A sub P of X, 1/2 K X squared. So I have this amount of energy. Now this amount of energy is released, and I see the object moving with velocity v equal how much? 1.2 meters. 1.2 meters. So the total energy that is released is kinetic energy now. So if you want, it's like putting here, this is the position A, and what is the position B? What is the total mechanical energy at the position A? Well, it's kinetic energy at the position A plus potential energy at the position A. But at the position A, there is no kinetic energy, and there is only potential energy stored. Okay. What is the mechanical energy at V? The mechanical energy at V, this is the position V, is only kinetic energy. And what it say our theorem? Our theorem said if there is no external forces acting on them, there is no friction, for example, the mechanical energy is conserved. So the equation will say that the mechanical energy at the point A, 1/2 kx squared, will be the mechanical energy at the point V, 1/2 mvv squared. So I have this equation, and I have the other equation that say that the force is 35 newtons, and the force is K by the compression. So I have two equations. One equation say that k x squared is equal mv squared, when m is, can you tell me what is m? M is 0.12 and v is 1.2. 0.12 and b is 1.2, I said? Yes, 1.2 squared.
Yeah.
So the first equation say that the m is 0.2 and the v is 1.2. So k by x squared is, Meyer, can you tell me what is 1.2 squared? It's 144.
Yeah.
Multiplied by 0.12 is 0.15 maybe.
0.1728.
1728. Okay, 0.1728. And the other equation that I have is that the kx is the force, it say at the beginning, that the force that sustains the body is 35 newtons. So if it's 35 newtons, it means that the k by x is 35. K by x, 35. So what I will do with this? So I have two equations. Here is solved. So I have two equations. The first equation say that 1/2 kx squared, 1/2 kx squared is 1/2 mv squared. It would say kx squared equal mv1 square, sorry, mv1 square, so I make a mistake here, okay, and the other equations say that kx equals 35. So the x is 35 divided by k. So I will plug in this number on the first equation. And I will have, I will have that k by x squared, 35 divided by k squared. 35 divided by k squared, so this will be 35 squared divided by k. Wow, so many mistakes I did. Equal 0.12 by 1.20 squared. So the k, will be 35 squared, right? Well, why 35 squared? K by x? Yeah, it's 35 squared. The k will be 35 squared divided by 0.12 by 1.20 squared. So, can you do this calculation, Meyer?
Yeah, 1 second. But I did this problem earlier with a tutor, and we didn't do 35 squared. It was just 35. Well, never mind. That was for finding the x, not for finding the k. Never mind.
Let me see if I did a mistake. 1/2 kx squared equal mv squared, kx squared equals 0.12 by 1.2 squared, kx squared, and kx is 35. So x is 35 divided by k. I plug in on the x squared, will be k equals 35 squared divided by k squared. K divided is 35 squared. 0.12 by 1.20 squared, this is this, so the k is this one, yes.
Okay, so the answer is 7,089. 7,089. 7089. 0.12 doesn't really matter.
Okay, 7,089 newtons per meter is the spring, is the constant of the spring, and the problem is asking the initial compression, right? So the initial compression will be here. 7,089 plus x equals 35. So the x is 35 divided by 7,089. So the x will be, Meyer, let me know.
Plugging it in right now, 1 second.
Yes.
divided by 7089 equal to 0.0049 meters.
Wow, 0.049 meters. Okay, 0.049 meters. Are you sure you did this calculation correctly? Can you
It
check?
is because the answer is in centimeters, so then you just move it up by 2, so A is the correct answer here.
What do you mean that the answer is in centimeters? What is the
We
centimeter?
found X as in meters, correct?
Yes.
And then it says in the question, the internal compression of the spring in centimeters
Oh,
is closest
okay,
to.
is
So
correct.
A is correct.
Yes.
But
This is the correct. I did it correctly. So
Professor,
I didn't read.
wouldn't an easier way of
But
solving it just
you
just
know,
be
let me say something. You know that they say a lot of information about what happened in this after, about the velocity. Pure rubbish, the coefficient of kinetic energy. Pure rubbish. This is something that they don't give you the information. This information about, for example, the velocity of the object here, this information about the velocity of the object here, knowing the velocity here will allow you to find the h. But the problem is asking about the compression. So the compression is this one in meters, and you don't need to do. It's a short answer. The force is 35. It's K by X is 35. And the other equation is the potential energy equal to the kinetic energy final. The total energy initial is the total mechanical energy final, that is kinetic plus zero potential. So these two equations solve for X. That's all you need to do in this problem.